Hi, and thank you for joining us today. First, I wanted to let y'all know to check out our educational papers and talks on all of our social media platforms. We're always posting stuff. I try to put up at least 3 to 5 a week, sometimes more than that, depending on how much time I have on my hands. But those, you'll find tech tips and all kinds of good webinars and other things that we've done for you. We have a quick and informative presentation for you today, and I am happy to be joined by four of our most seasoned engineers here with a combined expertise of about 90 years. Imagine that, 90 years of IT experience. This should be great, and I'm excited to go ahead and get it started. So with that, I will thank y'all for being here with us today again and pass it over to Henry.
Well, thank you very much, Stephanie, and thank you very much, Brandon and Jerry. And Harold's not on the call with us right now, but everybody in the team contributed towards this. This is a lot of knowledge that we're going to cram in a short little period, and we're excited to be with y'all. So thank you very much for joining us. We've got a ton of information to kind of hit, and we're going to try to not dig in too technical, but a little bit because it's a little technical in nature what we're going into. Today, what we're going to discuss is, in short version, the current state of server technologies, and then we're going to dig into a leading edge server technology called hyperconvergence or hyperconverged technologies. From there, we're going to talk a little bit about how it's widely available for almost any size business nowadays, why it's really cost effective, and some of the major benefits of hyperconverged servers and hyperconverged infrastructure. Now, we can't cover everything, unfortunately. It is a tremendous amount of information that's possible to discuss here, and we're just not going to be able to cover it all, but we're going to give a really good kind of a capstone piece and an introduction to the technology, some pros and cons, and I'm very excited about where we're able to present, and I think you're going to find this very educational. That said, as a kind of a primer, let me just dig right into it, and then we're going to get around to some more details. But at the very highest level, what is hyperconverged, or what is hyperconvergence or hyperconverged servers? It goes by a bunch of different terms. Well, the definition of it goes by about 1,000 different ways. If there's 20 vendors, there's 20 that are selling what they call hyperconverged solutions. There's probably 20 pretty unique definitions. One of the major vendors that sells a product that is classified as a hyperconverged infrastructure is VMware. They've been a leader in hyperconverged from very early on, and they've been a leader in virtualization from a long, long time ago, from the pretty much the beginning of the mass introduction of that technology. Well, according to VMware, and you can read the definition on the screen, but short version from there is that it includes a hypervisor for virtualized computing. A hyper-converged environment includes software-defined storage and network virtualization. So Henry's shortened version of it of kind of a generic definition that probably will cover most of vendors' implementations of this technology is that storage, CPU or processors, and RAM, and usually or sometimes networking and other resources of a server data center environment or the big rack of stuff that you've got in your closet are all virtualized on similar hardware components for just incredibly increased scalability, resiliency, and other benefits. So that's the the shortest possible version of a definition of it. Now, digging into it a little bit, what I'd love to do is introduce y'all to Jerry Solis. He's our senior project manager. He's been doing this for forever. And Jerry, can you give us a little context or a little history of kind of like, I think it might help to understand hyperconvergence if we see where it came into place and where it fits into the server puzzle.
Yeah, most definitely. So I think, probably a good place to start is kind of going back to the beginning. of server infrastructure and the role of servers in our life. The first realm of this is one physical server. Okay, that you would load that device up with memory, with CPU, and with storage. Okay, with disk. It would have one operating system installed upon it, typically Windows or one server operating system, and it was used to perform really one purpose. Okay, so it would provide kind of one service, whether that is serve as an Active Directory server, serve as a file server, serve as an application server for, say, QuickBooks or an ERP type system. But the key piece is it would have one system that and one purpose that was running on that physical server. Again, kind of the downsides of this were multiple because of the way the systems were all put together. You did have to size that server for your greatest need. Okay, so there was no scalability in the resources that you would apply. Okay, you would have to use all of you would have to purchase all of the resources you would need for your busiest day. Okay, and your busiest use. You also would have a tremendous amount of trouble being able to complete upgrades and do them with any sort of savings from a finance perspective, because every time you had to upgrade, which was often, these systems were purchased, and as technology was rapidly improving, you'd upgrade these systems every 3 to 5 years, and each time you upgraded them, you had to purchase additional memory, you had to purchase additional storage, and then include extreme amounts of downtime to be able to bring the device down, install the new hardware, and then be able to bring it back up, test it, install drivers, those types of things. So it was not only expensive, inefficient, but it was also extremely time consuming whenever upgrades were needed. The great news is we took a big giant leap from that world into what we called those days what we called virtualization. Okay, and it truly was a giant leap in terms of what we were able to leverage physical server hardware to be able to accomplish. Okay, so again, you would load that one physical device up with the disk, the CPU, and the memory that you would require, and then you would add what's called a virtualization OS or operating system. You'll also hear this called a hypervisor. Okay, so common names for that: VMware, Microsoft Hyper-V. Okay, those types of operating systems you install inside that one physical hardware, and then be able to leverage it to provide multiple different servers virtually. Okay, which is where the virtualization concept comes from. On each one of those individual virtual servers, you are able to provide multiple operating systems. Could do Windows on one, Linux on another, and a Mac OS on another, if you need it, all on one physical device again, and allowed you to run those multiple devices all at one time. Okay, so this was a huge upgrade and a huge development in server technology and in how we serve our clients, our devices, the things they need. Okay, so obviously you're now running multiple devices on one physical server, so you're saving on hardware. You only need one device to run 4 servers, for example. Less cooling, less power, and less maintenance. Right, going forward, you still only have that one device. Okay, it offered a great range, or still offers a great range of disaster recovery capabilities. You can do replication, you can do standard backups, you can do snapshots inside the device itself that will allow you to recover from disasters. And upgrades and maintenance became a lot easier. Okay, you were able to swap pieces and parts, be it CPU, disk, and memory, in and out as you needed to, as well as being able to allocate those resources to the individual virtualized servers. Okay. So if you had a server that was running and you said, oh, gee, I need additional disk space. Okay. In the old world, what you would have to do is go out and buy new hard drives, shut down the server, install those new hard drives, configure that storage, bring it back up, and then bring the server function back online. With virtualization, it became a little bit easier. You could allocate resources already in that physical server to the virtual servers and slide those up and down as you needed to based on the resources you needed. Okay. The downside was it was still tied to just the hardware that was in that device. Okay. And anytime you did a physical upgrade, you still had to bring the whole device down and do maintenance. Okay. So it still required that downtime and that outage. And now every time you do maintenance, you're not just bringing one server down, you're bringing four down. Okay. So it almost kind of increased the impact of maintenance operations when you did have either, a failure or storage. So one of the things that kind of came around out of that is trying to separate out some of the pieces. Okay. And one of the first pieces that got separated out was the disk. Okay. And the actual storage. And Brandon, being our SAN expert, I'll just go over to you if you want, Brandon, to tell us a little bit more about that.
All right, Jerry. Thanks a lot. Yeah. So this was one of the kind of next steps of evolution. And I say that the storage area networking has been around for a long time. It probably sort of came on the scene about the same time as virtualization, maybe a little bit before. But initially it was used for big data warehousing type deployments and stuff like that. Where it comes into play when you combine it with virtualization is the ability to get some really efficient use out of your storage. And you can start to do some different things even on the virtualization side. It allows you some flexibility, some more highly available configurations that you don't have in a single server. So what happens when you combine these two things with the virtualization and the dedicated storage system, a SAN, is you've got these front-end servers that are all your compute resources. They have CPU, they have RAM. Generally speaking, they don't have disks or they don't have very large disks. Nowadays, we use kind of small flash type storage in them just to run a minimal operating system, and that's about it. All of the real storage happens on the SAN. So your virtual servers, the virtual server operating system, as well as any data that it might have, is separated from what we think of as a traditional server. Now it's all residing on that SAN. That allows you to scale up the compute resources pretty quickly and easily. You just add in an additional server that is loaded up with CPUs, loaded up with RAM. You connect it into the storage subsystem, and now you've increased your kind of running working load capacity. On the storage side, you build some efficiencies in there because now you've got one big pool of disks, one big pool of storage that you can divide up for each workload. You can assign so many terabytes to this application, so many terabytes to that application, and you get much more efficient use of your storage space. There's some additional technology that makes that better, deduplication and compression technology that actually happens in that storage subsystem. It's offloaded from the servers and again, makes it a lot more efficient. Expanding the storage a lot of times is you add an additional shelf of disks, kind of like what's in the picture. You keep stacking those and you can get more and more storage, more and more reliability. There's ways for redundancy that's built into those, and different vendors work different ways, but for the most part, you can build a very high degree of reliability, data protection, different types of RAID levels. And in the more modern ones, it's more of a software defined type RAID than a traditional one, but still the same principles apply. So there's a lot of advantages that came into that. And it also gave you this ability in, for instance, in the VMware terminology, doing things like DRS and high availability fault tolerance, where you can move running workloads between physical servers to do maintenance without any downtime. If you have a failure, it's very easy to recover. It's just a matter of pressing a button or an automated process of starting up that virtual server on one of the other hosts that's not failed. So a lot of resiliency came into it from there. Some of the downsides, though, I mean, it's not all upsides. Some of the downsides of doing this is it's pretty expensive on the storage side. You're saving money in most cases on the compute side, those front end servers that are running your CPU, your RAM resources. But you're putting you tend to put a very high premium into the storage piece of it. These are purpose-built devices most of the time. They're proprietary parts and drives, and then you've got the networking layer in between it. It might be fiber channel, it might be iSCSI or FCOE. There's several different technologies that are common that provide that data layer between the hosts and the storage subsystem. That's kind of costly to maintain as well. From the standpoint of purchasing it, licensing it, maintenance, and upgrades. And in most cases with these, every 5 to 7 years, you're looking at a kind of a forklift upgrade. I mean, you've really got to bring in an entirely new system and do a fairly major project to migrate from one to the other. And there's tools that can make that easier, and you know, it's not as bad as it was maybe 10 or 15 years ago. But still, I mean, it's a big project. It's an expensive project. It's time consuming to do that. So, you know, there are some alternatives now. When we start talking about hyperconvergence, that gives you, in some ways, the best of both worlds, because there's a lot of advantages to using the virtualization plus SAN, but obviously there's some disadvantages that come into play as far as how you can scale up and how you can kind of continue to grow your infrastructure without having to do these big major forklifts, without having to deal with sometimes the interoperability or compatibility issues that come up with having this storage vendor and this fiber channel vendor and this host vendor, and having all those things where you have to deal with a bunch of different people to help you resolve an issue. You have to train your staff on a bunch of different things and keep them up to date on all these different technologies. So hyperconvergence really provides an alternative to that to make some of those things more efficient.
Thank you, Brandon. This is a relatively complex subject, and visualizations don't do it well enough justice at this kind of level when we're talking about it. But we still have a lot of clients at this level of sophistication, and they're in a pretty good way, aren't they? In a lot of spots. For most of our customers that have this degree of sophistication and the redundancies, you mentioned some of the potential pitfalls, and I think that's where we really are excited about hyperconvergence, is the like you mentioned, like that stuff I didn't draw in the PowerPoint here of the switches in between and the 14 different vendors that it usually takes to put this all together, because you're dealing with the hardware vendor for the SAN, the hardware vendor for the hypervisors, all the stuff in the middle, the switches and the cables and the fiber optics and the and all the other stuff that makes it pretty complicated. Are there any other major downsides or upsides on the just kind of OS virtualization with a SAN that are worth talking about at this point? Nothing huge? All right, we're going to move along then. So what's next? Kind of as we talk about the idea of evolving your server environment and evolving your infrastructure, and maybe taking advantage of the upcoming efficiencies in newer technology, this concept of hyperconverged, I think, is probably the evolutionary next step. And kind of at the highest level, just a visualization of it, hyperconvergence means that each, and kind of what it looks like from a physical perspective is that each node almost always of a hyper-converged environment has, it feels like a step backwards at this point, but it'll make sense, I think, in a second. But each node has disk, CPU, RAM, and they have an operating system on each node that is kind of this hyper-converged virtualization operating system. So it's a newer version of the operating system, and often they'll have switching capabilities or other things built into those nodes that you typically wouldn't see in the previous slides of just the operating system virtualization. Some of the bigger upsides is that we're going to see, and we'll walk through some of these scenarios in a second. And Brandon, I'm going to bounce it back to you and Jerry to dig into details on this. But some of the big upsides that I see when we're talking with customers about their data centers is that expansion of the entire environment can be done with almost no downtime. You just literally add those bricks of another node. You see simplification now, like we reduce some, if not a ton of vendors in the environment. And there's simplification in the future. We'll talk about that from administration capabilities and the knowledge set that it takes to administer it. Also to when it's time to do refresh, if you need more processing power, or if you need to look at, like, it's been 5-6 years, it's time to do a major refresh. It's way simpler. In many cases, in many vendor solutions, we see dramatically reduced costs for that whole data center environment, to the tune of like a third, a half to more of your costs just go away on a 5-6 year total cost of ownership. Other stuff is that I just love seeing the increased capabilities that we can now offer data center environments and our clients, because they can do so much more. The IT departments that have this infrastructure can say yes more to the boss when he says, hey, can we do this? Or can we spin up a new server? Or hey, can we be prepared for this, that, or the other scenario? Or hey, what happens if we do X? They're able to respond favorably without starting with, yeah, but it's going to cost, or not quite as much. So kind of thinking through that. What's the when we look at this, and Jerry, I know you're kind of in the middle of an offsite expansion for one of our environments, but when we think about how do we expand and how can a hyper-converged infrastructure benefit a business, one of the cool things is its offsite or secondary site replication capabilities. Can you dig in a little bit and tell us about that?
Sure, most definitely. So with hyper-converged infrastructure, you can set up the nodes that Henry mentioned earlier work together in what is called a cluster. Okay, and they tend to operate together as that cluster. Okay, and while they may each have their own individual storage or CPU or memory, really the hyper converged virtualization OS allow them to really work like they are one system. They are one physical system, and all of those resources are pooled together and work together. Okay, so that gives you that ability to be able to add bricks, right, and add them on top. One of the second biggest advantage is it makes offsite capabilities so much easier. So in before hyperconverged, what you would do is you would have a production system, and you would have something out in the cloud, okay, that at some period of time would take backups, and it would push those backups up to that cloud system. Okay, and that cloud system would store backups, and that's how you did offsite storage or offsite backups. One of the nice things about hyperconvergence is really that offsite system becomes like a production system. Okay, and you can link the cluster that you have on site with the cluster that you have offsite. okay, and they become pairs, if you would, okay. And with that hyperconverged virtualization software, you're able to replicate data from the production system on site to the off-site system much easier, much more real time, and much faster. Okay, to where that system in the cloud not only not only will it have a better version of the data, i.e., it's within 15 minutes as compared to a backup, which maybe is a day old. It also can come on much faster because that hardware is already there, the operating system is already installed, and the system that you're running, okay, the Active Directory server is truly already there as a snapshot, and it's a matter of just starting the snapshot and bringing it online. One of the ways we always talk about this is it does give the benefit of a public cloud, this big, huge public cloud that honestly seems scary to a lot of small businesses because of its access and its ability. It gives you that benefit while you're still able to control the hardware and the pieces of it yourself, okay, and being able to manage it. So you get the benefit of the public cloud because it's out there, it's in a different location, and we can access it if something were to happen to our physical facility or our physical devices. But it still kind of has all the benefits of that private cloud too, in the sense that you own it and it's yours, and it allows that replication almost real time for all servers. In a recent scenario, we had to stand up and use some of our offsite replication capabilities for a large customer. And whereas
hang on,
sure,
switch to the next slide. You segued beautifully, and you didn't even know it. But what happens with hyperconverged infrastructures, again, set up right and kind of in general, because there's 1,000 vendors doing things that are kind of in this space, but set up right, what happens when we have a failure at maybe, what might be deemed the primary data center?
Sure. So we really kind of have two types of failures. First, the first type of failure is some piece of hardware inside that main cluster dies. Okay. So let's say, for example, a hard drive fails. Yeah, one of the nodes goes away. Okay. The nice thing is inside that on-site cluster, okay, the other two nodes, the two remaining nodes, sense that middle node is gone and is no longer there. And real time, without a server becoming unavailable, the workload is spread amongst the two remaining nodes. Okay, because that data and that information is spread across the different devices for real time utilization. So if you were to lose just one physical node, right, in the environment, the other two in this image, if you would be able to pick up the workload. Okay, and just real quick, I want to tie that back to our historical lesson, just because I think it's interesting to kind of think about what it was like back then. If you had a CPU fail back when we had one server, you were down, and you were down for days. Okay. You were down until you could get whatever physical device it was that failed. You could get it back in. You could get it in stock and in inventory. You can install it in the device and then bring that device back online and kind of continue that troubleshooting. And you would often see corruption of data, or or in the worst case scenarios, the device just non-responsive and you have to restore, from a complete backup. All while every employee at the company is kind of breathing down your neck saying, what's going on? Why is it down? Why is it down? Why is it down? Right. That changes a little bit with virtualization, right? You can kind of slide some of those resources, and maybe with just virtualization, maybe the systems that are left or the systems that are online run a little slower. Okay. They don't have the bank of resources that they used to have. And so they can kind of run in what's called a degraded state, right? And those kind of things. But then As you jump forward to hyperconverged infrastructure, the impact of that one device going away, your users wouldn't notice a difference. Okay, the QuickBooks server is still available, and everybody's still processing transactions. Okay, and so it kind of becomes, in IT, one of the nice things is, I had I had a mentor in the industry kind of tell me, you always want to be the duck on the water, right? And above the water, you're sitting and you're floating nice and pretty, and you look nice and clean and sleek. And under the water, those little legs are moving about 90 miles an hour, right? Trying to get things fixed. And that's kind of what happens with hyperconverged infrastructure, right? Under the water, behind in the IT room, right? You can talk about how you're trying to get that node back online and warranty repair and get that device fixed. But above the water, where all your users live and exist, everything looks nice, slick, and smooth. Okay, which is really cool and really neat from an IT perspective. Okay, so that's one type of failure. That is, in my building, one of my systems died, a piece of hardware failed, a hard drive, whatever it may be, and I'm going to keep running. Okay. The other type of failure that really becomes a lot more beneficial with hyperconverged infrastructure is this offsite idea. Okay. So let's say we have a hurricane scenario, okay, where you lose access to your physical infrastructure. Okay. You cannot access your building. Okay. Let's talk about a scenario where you lose internet connectivity, right? The ISP has failed and you have lost internet connectivity to a facility where the systems are housed. Okay. That's where the offsite capabilities come in. And kind of talked about that a little bit, but it becomes your disaster recovery scenario, right? Real time while the systems are running, you set it up to be able to those systems to be able to replicate to each other. That replication happens real time in the background, okay, and can happen as quickly as every 15 minutes, right? You're replicating snapshots to this offsite system. When your production system goes down, you flip your services to the offsite location and you're back up and running. Okay. Like Henry says, done right. It's not instantaneous. It's not, nobody notices, but it's very quick. I would say you could have it in minutes if you have the proper DNS infrastructure and failover infrastructure from a networking perspective. The systems are there and running. All you'll have to do for the systems to come back online, honestly, is pop them back on and turn those on. Interesting note, and I just noticed it at the bottom of the slide, and I was running through this thought too as I was talking. Replication does not replace backup. Yeah. Those are two critical items. It is just because you have replication does not mean you don't need backup. And just because you have backup does not mean you don't need replication. They are two different things and they service two different purposes for environments. As Henry, I know you have that conversation pretty regularly with customers.
Yeah. Just because you have 4 tires on your car doesn't mean you don't need a spare.
That's right. That's absolutely right.
So thank you, Jerry. And folks, this is there are literally 30, 40 scenarios we could go through about how this can play or that can play. And it just gets really exciting when you look at the possibilities and the capabilities against each scenario or in the face of each scenario, but we just can't dig into all of them right now. So unfortunately, we got to kind of move along. But Jerry, thank you very much for kind of addressing those two things that we see often. I mean, hardware fails. Doesn't matter who you buy it from. And here in Louisiana, hurricanes happen. So
sure do.
Yeah, so,
they sure do.
They're both things that we immediately talk with customers. So kind of walking through the futures, because the future also happens is that hyperconverged scenarios and infrastructures allow you to scale and grow rapidly without these big, massive forklift upgrades. What we see, especially in the SAN environment, is that like Brandon mentioned, like every 5 to 7 years, they're end of life, and you got to spend another $250,000 starter on a new SAN or something like that, or it's just a huge expense on a new storage area network. And they're hard projects, takes a lot of coordination, usually some kind of downtime. But with a hyperconverged environment, you just add a new block in, and you slowly migrate, allow the hyperconverged software to just migrate the servers up slowly and at its convenience up to the newer nodes. And it can be done with in many software and hardware hyperconverged vendors environments. Many times this expansion can be done with zero impact, like the servers don't miss a packet. So it's pretty amazing. And the cool part about this from a cost saving perspective is that those old nodes can stay in your environment, providing what resources they have forever, asterisk, until they die. But we have some customers who run in hyperconverged environments, and they've got literally 10-year-old nodes in their environment that have a little bit of disk, one or two processors, and a little bit of memory, and they're able to contribute towards the whole farm or the cluster, although they may not be the leading hypervisor or load bearer. They can at least help, so you can continue to recoup your investment in those for a very, very long time.
Henry, one thing of note is that, with ASIC technology that you have on SANs and traditional hardware, those cycles of development is a lot slower. It takes a long time to develop an ASIC chip and get that out in the market. So your SANs typically don't refresh and come up. Whereas with hyperconvergence, you're using you're basically using general compute, and so those refresh cycles are a lot faster. So you're keeping up with the latest CPU and memory and all that. You're not waiting for some ASIC chip to come out and then be literally dated within 6 months. It's no longer able, and they have to go back to the engineering and the firmware updates, and you don't deal with usually RAID adapters and all that specialized hardware. It just simplifies the back-end infrastructure.
So when HP receives, or HP or Dell or IBM or whomever, Lenovo, whenever they receive the newest processor from Intel, you can start using that. Again, depending on the vendor you use to implement a hyperconverged environment. As soon as that processor becomes available in the market, you'll see hyperconverged vendors deploying it. And that's not the way with SAN stuff. We'll see lag time of years sometimes in those environments. So that is very, very true. So look, let's get into the nitty gritty now, and I want to dig in and explain the actual technical nuts and bolts of how hyperconverged. We've been very glossy here, and we've talked about the kind of the sales brochure for all these different vendors. So what we thought might be helpful is if we really dig in and show you exactly technically how hyperconverged servers environment works. So here goes. I can't. Unfortunately, there are literally there are more vendors selling their version of hyperconverged infrastructures and systems than I got fingers and toes, and all of them have substantially different components that makes digging into one or the other in very technical details almost impossible without days and days worth of time. So we love and use solutions from a large variety of vendors, Red Hat, VMware, Microsoft, Scale, Datacore, all these guys, and we've found real pros and cons across all of them. And what we've demonstrated thus far, I think, is a pretty good introductory idea of what is common across them. There's probably some other things that we missed, but hopefully we've kind of whet your appetite a little bit. and kind of explained a little bit of the idea. So kind of thinking through and summarizing, how can hyperconverged infrastructures help your business in your data center? You get a lot of things that are benefits of going to Azure and AWS and the big public clouds without that, like high availability, simplified scalability, and massively improved disaster recovery capabilities. You get significantly reduced, or in some environments, a single vendor for the whole data center stack. So it gets you a lot of benefits, like reduced compatibility problems. You eliminate a lot of inefficiencies. And that means you get to reduce costs in most environments, most situations, because you get to use 100% or almost 100% of that processor that you bought, and the RAM and the disk, instead of what we typically see people using very little bit of it for 95% of the time, and maybe Monday morning at 8 they're using closer to 100% of their resources. If it's easier and simpler, that means it's easier and simpler for your IT staff and your IT departments and your teams. They have less training. And there's less work for them to spin up new servers and new hardware. Reduce cost of growth and maintenance. Most of these environments have no forklift upgrade path. You don't have to throw everything out to get new stuff in. And that means, in general, a real reduced total cost of ownership. So there's just a lot of pros. There's a lot of things going in the plus column for hyperconverged infrastructure. And in fairness, I think it's important to note that while we've talked about generally 4 or 5 generations of kind of server technology from the last 20 years or so, is that where it's all going to stop? Is this going to be the end of the server? And unfortunately, I got to tell you, I think it's probably not. What we're seeing in production now is not just operating system environment like Windows virtualization, and storage virtualization and networking virtualization, like we've just kind of walked through, but now we're looking at like application virtualization. So like the actual program we can distribute across a bunch of different servers and a bunch of different platforms and data centers, which is really cool. It's sometimes referred to as containerization. And there's 2 or 3 kind of really heavy buzz vendors out there that are talking about it, and the big data centers are implementing stuff from them, and kind of where we see technology going, and very likely we'll be seeing it in more and more of our customers' environments is Kubernetes. That's a big containerization or application virtualization solution, and Docker. Docker is another big one. And before we get done with this, at some point or another, I'm sure we will probably get to Cybernet and the T100s roaming the earth, but I'm just kidding. Hopefully not. But no, hyperconverged solutions are not the end. There's more stuff going there. It's a very good spot that we really are encouraging all of our clients with a few servers to look at, because it has a tremendous amount of upside and very little downside.
It's just in general getting away from the hardware and moving up the software stack, and
Yep.
Software and applications are where it's at, and we see that with our own personal devices with the apps, and that's just where we're going. It's moving away from the IT guys and the guys that know that, and it's moving into the consumer, where the consumer can consume what services they need, and that's where it's all moving.
Yeah, you bet. So kind of wrapping up in summary, I really appreciate y'all visiting with us and taking a minute to dig into this. And if you're curious and want to learn more, holler at us, give us reach out to us. There's a couple different ways at the bottom of your screen on how you can. Call us at 225-751-4444 or email us at ask@turnkeysol.com. And we'll be glad to sit down and visit with you. And even in most environments, conduct a no-cost, no-risk assessment of what you've got to see if one of these newer, more diversified, virtualized infrastructures would be a better fit for your business. And we'll even show you a roadmap for how we're going to make sure that it saves you money and gives you better capabilities. So call us 225-751-4444 or email us at ask@turnkeysol.com. And we look forward to visiting with you and answering more questions, digging into anything that you've seen here, and maybe answering some questions for you to see if it's a good fit for you. Down the road, I'd love if you will make sure and follow us on Facebook and Twitter. Check out our blogs. We're constantly digging into newer technologies, talking about what's going on in the cybersecurity environments, and a lot more stuff about business and technology and how we can make sure that we make technology work for you. So follow us and check out some of these social resources. You can start just at our website or social media, and we've got links to everything else from most of those. And with that, I'd like to thank my panelists and coworkers and partners here. Thank you, Stephanie, for making this all happen. And of course, I'd like to thank you very much for joining us today. Hopefully this has been beneficial. If you have feedback, comments, or questions, or have any specific topics that you'd like us to discuss in the future, please let us know. We look forward to being of service to you in this way as well. So thank you all very much. Have a great day, and we look forward to talking with you soon.